program manager at Catch Traffic Fund, and he's leading new technologies and international standardization at Catch. And he'll be going into some of these European-based standards during his talk. So why don't we start from there?
Thank you. A late good morning to everybody. Perhaps little words about Catch Traffic Fund. We are an Austrian-based company with also subsidiaries in US, and have been working quite tightly with IEEE, IEEE 11P, IEEE 1609, together with John. After the VIIC field operational test based on the 2006 trial standards of 1609, we accomplished in the time frame of 2008 to 2011 to finalize the 1609.x standards besides the security and realize the CSDOT safety pilot for field operational test. Catch is an ITS company, so we have many different fields of operations, from system deployment, system operation to product development. In US, you may know the EasyPass group in the northeast of the continent. Catch is supplying the onboard units and transceivers to the complete EasyPass group, for example. But we are also very active in this car vehicle-to-X technology, working on this technology since more or less 2006. And my talk is more or less an overview of the landscape in Europe, but also cooperations, similarities, and history with the US standards development. So it's quite a complicated landscape with a lot of stakeholders. The history goes back to US to the end of 19th, beginning 2000s, where the spectrum allocation happened. The 11A has been standardized, and the initiative for 11B is started. So in US, we see IEEE, ITS America, USDOT, SAE, RITA, etc. And this activity moved around 2004 to 2006 to Europe with Artico, which is the complementary part of ITS America in Europe, and ETSI as the European Standardization Institute, mostly known for communication. It's standardized, for example, the worldwide cellular communication technology, GSM. ETSI created then the technical committee for ITS, and ITS focused the so-called G5 technology, which is the wave of the US. There have been activities in ISO and SEN about cooperative ITS, but not about more communication, but integration and application part. And from these activities, two interest groups evolved. One is the Car Communication Consortium, where the major automotive OEMs have been the creators of the group, like Daimler, BMWs, Volkswagen, Audi, etc. It's a quite strong group. And recently, 1.5 years ago, the Amsterdam group, as the complementary group, has been created. This is more the infrastructure side, so the road operators, the cities, that kind of interest. Similar to the car is also existent in US, which is called CAN. So Toyota is part of this group, for example. Perhaps later John may tell you more about that. And finally, of course, all this stuff has a very global scope. ITU, the International Telecom Union, has been engaged also in some standardization activity and putting all these activities in the global scope. So I will a little bit concentrate on the ETSI specified protocol stack, which we call as the ITSG5 protocol, and later show you similarities and differences between WAVE and ITSG5. So actually the basic magnifier here is more or less one-to-one specified by ITU 8.11p, now 8.11 release 2012. And it is only a so-called profile created by ETSI, allocating the channels, giving some other structure to the channels because of local regulations in Europe, etc. We will see later, and also creating some kind of the ADAC parameters and similar in another context. But the hardware, so if you go to your chip vendors and purchase some chips for this technology, they are all compatible with each other. Then on top of this file mag, the ITSG5 specifies a GNetworking layer, which is standardized in these numbers EN203, 636, etc. So you may use them as for reference, and these standards you may download, I think, freely from the ETSI homepage. And similar to WSNP, so the Wireless Simple Network Protocol, ETSI standardized the BTP Basic Transport Protocol, which is a very simple protocol we will see in a minute. On top of this, the so-called facility layer with the cooperative awareness message and decentralized environmental notification message has been standardized. Similar messages are also available in the US standards, and some cooperation, some harmonization work has been done about this already. And on the very top, of course, applications which are very vendor dependent, so applications are not be standardized. OEMs put a high value that they differentiate themselves from each other with the application, of course. On the other side, via the same medium, it is possible to transfer IPv6, TCP, UDP, and all available protocols, but for the time being, it is out of scope because of priority of deployment. So the WAVE or SAE 2735 specific CAN is BSN, the basic safety message, for example, and the traveler information message specified in 2735 more or less corresponds to the DNM. The WSNP is similar to BTP. The major difference is the geonetworking in the ITSG5. In WAVE, there is no geonetworking specified so far. So it is resolved on the J2735 message level and application level. What I didn't designate here is a very interesting functionality which is called local dynamic map. Local dynamic map is located on top of the facility layer, part of the facility, part of the application, which creates a dynamic map of the environment based on the messages received from the vehicles or roadside in the environment to to give to the driver or the intelligence in the vehicle the specific means of action. So if we put the two protocol stacks side by side, the similarities are with the contextual equivalence is here. As I said, the only major difference is the geo-networking. We will see in a minute what is the reason of geo-networking as the G5 had foreseen. By the way, I forgot to say that security is based also in the ITSG5 context more or less on 1609.2. So ITSG5 applies also elliptic curve cryptography, also needs PKI, and all the messages are more or less in broadcast mode, needs some certificates for signing the messages, for authentication of the messages. Coming back to the file layer in the ITSG5 context. So they are similar to US, 70 megahertz allocated, although from the 70 megahertz only 30 megahertz are active today, which are the 176, 178, and 180. So the major channel for vehicle-to-vehicle safety communication is the 180, which I designated here as a CCH. All this allocation is standardized in the EN 302.663, which is the so-called profile standard to the 802.11 released version. There are two additional channels, 172 and 174, which are foreseen for non-safety, and two additional channels reserved for future app not defined yet. And there is additional the standard wireless LAN brown band, which is called as the ATSG5C, where you can do any application you like. So the correspondence of the channels, how it is utilized in the US and in ITSG5, you see in the color depicted below. One difference is in Europe so far no 20 megahertz channels defined in the profile standard. This was awaited a long time, and the decision was because of co-channel interference, this would be not beneficial. So this is an overview of the European frequency scheme. As Jim also as the chair of the pilot team addressed the frequency allocation issue ongoing in US because of 11AC. Similar process is also ongoing in Europe. There was a request for more channels for 11AC. So I'm in the 5 GHz band. I wanted to show you the scheme in Europe. This is an excerpt from also the ETSI document. In addition to the wireless LAN or the ITSG5, there is also a tolling band, which is called the SAN-DSRC. It is a 2 × 2 5 MHz band with a totally different technology. So here you see the overlapping channel sharing or not sharing scheme. The European Commission initiated a study in the European Frequency Authority, which is called CAPT, in the subgroup SC24, and the evaluation is ongoing since end of September. So we have to consider, if we do this evaluation, two major points, which is of course the physical interference. So what happens during the coexistence? Co-channel, adjacent channel. But we need also to evaluate the capacity, because in the work of the vehicle-vehicle communication we recognize the capacity of allocated channel bandwidth is not even sufficient for vehicle-vehicle communication, so there are means defined how to cope with that. I come back to this, which is called congestion control or decentralized congestion control. There are also similar solutions called and defined in the US DOT safety pilot, I think. John may tell you a few things about that. Oh, okay, thank you. So, a little detail about the BTP, Basic Transport Protocol. So, as I said, it is quite simple. It is the standard MAC and LRC header from A to dot. The geonetworking header and BTP header and payload like. The BTP header consists of a destination port and source port, indicating, for example, a CAN message or a DNN message, and the payload may be CAN, DAM, and future other messages. So why geonetworking? Geonetworking because we want to address not individual vehicles, but areas, vehicles located in areas. So geonetworking enables addressing scheme for point-to-point, point-multi-point, anycast and broadcast. The difference between anycast and broadcast is in the area where the message broadcasted is broadcasting only by one for anycast and broadcast by all receiving parties. Specific of the geonetworking, so the area description, for example, is a specific which may be circular, rectangular, or elliptical. Scope may be single hop or multi-hop, so you are addressing multiple vehicles in distance. Service may be request or response or reply, and traffic class, buffer, store, and carry forward or channel of load. So you may use a second channel of offloading the load if it's a lower priority, for example. So there are still a few points open for finalization, which is the security public key infrastructure, who will take care about this infrastructure, root certificate authority, long-term certificate authority, and pseudo certificate authority, congestion control, as I said before, and card profile, which means to establish a common understanding, common interoperable base of parameters from all of these standards. This is something similar like the Wi-Fi Alliance, ensuring a certain level of interoperability and performance criteria. Message sets, so we have seen the CAN and DAM messages. On the other side, some work is ongoing on the infrastructure side in the same ISA standardization, defining in-vehicle information, roadworks warning, prompt vehicle data, signal phase and timing messages. Here is close cooperation given also with SAE. For example, SAE as a front runner specifying already signal phase and timing and map messages, and the guys are very closely working here together. So for the day one applications and ITSG5 deployment, we may see certain applications like infrastructure to vehicle or vehicle to infrastructure, like roadworks warning, in-vehicle information, signal phase and timing, and prop vehicle data or prop traffic data. And on the vehicle side, emergency vehicle warning, dangerous situation, stationary vehicle warning, traffic jam, pre and post crash warning, hazardous location, and bad weather warning. The car consortia signed a MOU to start the deployment 2015, so those applications should be expected starting with 2015. I would say a more realistic scenario is like 2016 to 2017. Thank you very much.
Okay, we're running a little behind